Okay? So the topic before me, cloud computing security models. I like to take it from the scratch, the very scratch. I can see conspicuously three words. Three words: cloud computing, security, and then model. Okay, so my part. First, we'll be trying to see what cloud computing is, and security, and then models. So I think by the time we put them all together, we'll be fine. So I intend for this to be my guide through the presentation. Okay? And then the background. As technology evolves, you'll agree with me, even in our everyday life, not just in the computing, the tactics of cyber attackers, making it essential for organizations to stay ahead. And then the cyber security trends are reshaping the way businesses safeguard their digital assets. Okay? Well, don't worry. If you see any technical terms, we're going there. So today, cybercrime works like an organized business. We've had a lot of that. So the speakers that have come before me have, one way or the other, made my assignment simpler, because some of these things are recurrent decimals now that have been mentioned before now. Today's cybercrime works like an organized business. One group finds the weakness, another builds the tools, the other takes care of the money. But all of this happens in an organized manner. All right, like I said, taking the words apart, cloud security computing, we're going to look at concepts of security in the cloud. So the topic talks about security in the cloud. What is the cloud? What exactly are we talking about when we say cloud? There is an attempt here to tell us what, or to remind us rather, what the cloud is. Cloud computing is the delivery of computing services over the internet, of course, as to access and use resources on demand. Take note of on demand, without owning or managing any physical infrastructure. Infrastructure such as servers. At some point in time, we have all been on maybe a FEDGEN server, and the man from MoneyPoint just did a delivery. How many of us have had transactions on that platform? MoneyPoint? Yeah, that means at one point or the other, you have been on their server. Agree? You have been on their server. And that means you have been in the cloud. Every day, some way, somehow, if you have a bank account, you have been on someone's server. So you have been in the cloud. So you'll agree with me that you're a stakeholder, and what we are discussing concerns you one way or the other. All right? Then, if we say security, take it to the contemporary. You live in a house. You have concerns, you have property in the house, and then you want to safeguard. The same way security is in the contemporary. Please bring it here. And it's just the same. When you say security, it means you have something to protect, something you want to look after, something you want to keep away something you want to protect. So cloud security in this context refers to the technologies, the policies, the procedure that we use to protect. In this case, what we have at stake is data, the applications, and the services in the cloud computing environment. I hope you are following me. Okay? So as organizations increasingly move to the cloud, I just cited instances now, and like everybody is there. In today's world, you can't shy away from it. In fact, if internet goes off 5 minutes now, we see persons complaining. Sometimes it's like they are live wire. So we're all on the internet, in the cloud, plus continually, and the rate is increasing. The extent to which we're in the cloud 2 years ago, in fact, many, many more things are going into the cloud. So the essence for security. All right, so we already started answering the questions. But why is security important in the cloud? Why is it important? Or why is it as important? We try to see that all the advantages we have going to the cloud without security can just crash like a pack of cards. The interest we have built in the cloud, the things we have tucked away, the data, everything, without security, they can just all go down. Here I have like the good things we enjoy when we're in the cloud. Flexibility, scalability, cost saving, enhanced collaboration, and disaster recovery. All of them can be overshadowed by the risk of data breaches. I mean, if there's no security in the cloud, it's not worth it anyway. Still that, like we have seen, there's security in the cloud because we want protection. Data you have tucked up there has to be protected. And then we are doing security in the cloud because security is a joint responsibility thing. Even in the contemporary. When we say security, it's joint responsibility. You have your role to play, I have my role to play. Then we are all together secure. They say a chain is as weak as its weakest link. If there's a weak link in a chain, it's as weak, and security is as weak as that. So security is a shared responsibility. No matter how secured a team member is, if someone in the team is a weak link, then that security is broken down. So we all have to do security because we're all stakeholders. You don't want to be the weak link in that team. Then, right from yesterday, we've been hearing regulations, laws. In fact, extensively yesterday, when we were talking about code being somebody's right, copyright. We have laws that back so many things up. So we have to do security because there's so many compliance that we have to adhere to. Ignorance, they say, is not an excuse. So we have to be aware, we have to be security conscious because there are compliance to be made. There are regulations to adhere to. And rising cyber threats. We are going to draw majorly on this shortly. So for business continuity and trust, the past presentation centers around money. If you have had issues with Money Point before or you will not be in a hurry to go back to them. They have built credibility over time because of the kind of service they have rendered. So they have names to protect. That's why they should do security. And then we do security too because of insider threats. The Yoruba people have a saying. I will interpret. Biku ile o pani, tode o le pani. That means if the meaning is if you are not, if there's no, they believe if any negative, if any ill happens, it must have had an insider connection. It must have been given out. You know, they could not take Jesus down until somebody from the inside. Yeah, so there are insider threats. When we hear threats, we look without. But there are also threats on the inside. So that's why we're looking at security. I'm coming back to this rising cyber threats. Cloud platforms are frequent targets for threats. I'm saying we're going to dwell on this, and like I promised, this class is going to be highly participatory. Okay, so the realm of cybersecurity is a battlefield. What do I mean by that? So I like everyone to get ready and your device is ready. You just might be the next sub-instructor. Get your stay by. I may be calling on you to answer some questions. But thank God, the answer will just be a click of the mouse away, but you give it to the house. Okay? So let's enter the realm of cybersecurity. This slide says it's a battlefield. What do we mean by that? In a jiffy. I'm going to be showing you some statistics. I like statistics a lot because they paint pictures and they point directions. They analyze, and at the end of the day, you know where you stand. Okay. The landscape of changing threats. This is an attempt to see what threats are, how it has been, and of course where we are now. Somehow we will connect from the beginning. An attempt to see somewhere near the beginning, 1990. All right? So we said the threats. Okay, what's a threat? Let's say in the contemporary now, what do we mean a threat? In the contemporary. What's a threat? Sir? Something that could pose harm. Something that could be harmful. Oh, please.
Something that could be harmful.
Something that could be harmful. Thank you. Can I have someone say it in another way? Maybe the same thing, but in another way. Threat. Danger. Danger. A third one, a third opinion, a third version. A third version control. Another version, damage, potential damage. All right. So you can do what we are saying now that we know what a threat is. So there's always been threats. And we see this landscape. This slide dates back as 1990. Okay, 1990. Can you see clearly from the back? Can you see clearly? Ms. Onolapo, can you see clearly? It's not so clear? Huh? Oh, okay, all right. So, No, they said they can see it. All right, so someone, 90, what is he reading? Virus. So we used to have like a virus. But these days, do you get to hear virus? Do you get to hear virus? Rarely. Do you get to hear there's a virus on my system? Do you get it so often? No. Virus. Okay. But back then, there's a virus. You even see creepy things on your system. You see the activities. So that's where it's about that 90. Then there's this. Then we enter the era of worms. So some persons here will not know what we are talking about. Then we enter the era of worms. They say it's a worm, Trojan, all of that. And then as the graph increases, when the advent of the web came, all right, so we see but when I start saying ransomware, a lot of people here will identify with that. Am I correct? A lot of people here will identify with ransomware. So what is this? What am I trying to say? That over time, the landscape has changed. What do you think is responsible for that? Technology, maybe. And then these people doing these threats are also advancing. That's the background we gave. They also say in English that if hunters have learned to shoot without missing, what will the birds do? They learn to fly without perching. So as these people are as we are advancing, they are bringing the viruses, bringing in the threats. Both ways, they're also sharpening. Okay? So you notice that from the advent of the web, here, as at 2019, machine-to-machine attack. It's advancing down the line. Okay? All right, now, can someone, like I said, let's start with, can we start with you, Mr. Freeman? All right. Okay. Globe imposter. Check it out. Okay, frequent. Everyone can go ahead. I have globe imposter. Yes, we want to learn something about it. Are you there? Okay.
So Globe Imposter is a ransomware family that first appeared in 2016.
2016.
Initially mimicking the original Globe ransomware to detect victims. Is also known by the alias Fake Globe, LOLKEK, and has been linked to TZW ransomware family. Should I continue?
Okay. So, okay. All right, at least you know that it's a what? A ransomware.
What's it called?
Can you see now that this thing is big business? Like we established at first. Highly organized. But what do we want to note about the Globe imposter? Like in 2 years, how many variants? 4 variants. Are you relating with it? In 2 years, it has had 4 variants. That shows activity. Okay. What about WannaCry? WannaCry. Who will help us with WannaCry? I don't know your name, sir. WannaCry.
Okay, WannaCry is a ransomware attack that spreads rapidly, Started in 2017, exploiting
2017.
Windows, vulnerability. It actually encrypts files on infected systems and then demands Bitcoin payments to decrypt them.
Demands what?
Bitcoin payments to
Coin
decrypt them.
payments. Yeah, coin payments. Yes. All right. And in 2 months, WannaCry had 3 variants. 3. That means rapid changes. Even our applications, do they get updated or renewed that fast? I'm painting a picture here. Okay. And then we have established that the landscape, look at since from 1990 to 2019. Can you see the variance? Can you see the change? Can you see the landscape? So some persons are actively. You know, our presenter, Professor Tako, highlighted 3. He said, as you are also doing. So he said they will come. I'm just trying to show us activity. And then we have, in 2017, internal threats. That's internal threats accounted for 34%, which increased year by year. And then these threats. In the past, the main purpose of launching attacks was maybe just to show off. To show off. Somebody would just hack and say, for different motivation. But now, more attacks are launched for commercial and political purposes. Do we have examples? Examples. Okay. Mr. Oba wants to help us.
Thank you, ma. So I think early this year, most of the operating system that use Microsoft had an issue for over a day or 2 that they didn't function, and it was as a result of attacks. So
that's a big one. Did you hear the name Microsoft? Who would do that? What do you think would be the reason for doing that to an organization like Microsoft? Do you want to say something? Money, motivation, politics. Let's have an example of a political one. Okay. Can someone help me with the mic?
I'm referring to the hacks on Sony Incorporated by North Korea in 2014.
Thank you. What was the motivation? Okay, that's political.
Political.
Okay. All right. Can we look at this? Statistics too. I want to have your attention because you might be the one that will expound it to us. When I walk up to you, just tell me the one that strikes you. Tell us which one strikes you, okay, and what they could mean, possibly. Sadare wants to help us.
Thank you, Ma. I think I'll go for the one that has the highest money involved. And I think that cybersecurity to cost $8 trillion by 2023 and $10.5 trillion by 2025.
What would that mean?
Yeah. Cyber crime.
Hmm.
That, to me, I think that means that in order to mitigate this, companies, to mitigate this this volume of money, companies will have to invest heavily in their security.
Thank you. All right. You want to help us, sir? Let me give him the mic. Okay. You tell us your name.
Okay, my name is Femi Akerele. And the one that strikes me is the 2,200 cyber attacks happens daily, one every 39 seconds. It shows how vast and how easily it can happen to anybody, because this is a vast number of attacks that happen per second.
Thank you. That means as the clock ticks, every 39 seconds, there's an attack. So it's happening. Just reminds this reminds me of that era when COVID just came in. Huh? Before lockdown, it was looking like it wasn't true. What are they even saying? We just used to see it on the TV until they said the thing has entered Ottawa. It still wasn't real until the thing started taking some persons down, and they actually diagnosed them. And yes, so these cyber attacks, you may even think it's sci-fi, think it's fiction, until something happens. That's why we are doing this kind of, why we're holding this kind of session. Papa wants to tell us something.
Yeah, so it's rather a question, ma. Since there is monetary motivation into the cybercrime, from my standpoint of view, it's either you're for or you're against.
Yes.
So, what is African doing in terms of seeing opportunities from this, creating anti-cyber softwares and all of that?
Carefully, that's the essence of this class. Just be patient. Your question probably may be answered at the end of the session. So, all right. So, someone has expounded on the first one, showing us that these attacks are rampant, as high as having one attack every 39 seconds. All right. So, the cost of a data breach. When we say cost of a data breach, if we say a data breach, what would it mean? This one says average US data breach cost 9.5 plus.
So, just to expand on what a data breach is. So basically what data breach to me seems like is, I use the word an infrastructural cost that might come from a penetration attempt, or if a successful penetration attempt comes in. So I would take, for instance, in the banking sector, if any outsider or even insider has an access to sensitive information in the bank, it will most likely costs the bank. One, service level agreement is going to be compromised, and US has probably just recorded the known amount as the amount that has cost it's that breach has cost them within their service. So that's what I understand.
Thank you. All right, we all have projects we are working on, and then you have data. How many of us have collected data over time? I'm surprised I'm not seeing any hands up, especially in the bioinformatics. All right. Can you you're not telling us. Okay, just because it's also maybe a security breach. Your data is sensitive, but what's the sensitivity of your data?
From my own point of view, I'm working with medical data,
Mm.
and so confidentiality matters when it comes to patient privacy.
Just hold it there. You are a custodian of data, and probably you promised that you will not disclose the data. Maybe you probably signed some agreements, and then suddenly somebody takes that data and publishes it. What would that do to you? What will happen to your integrity?
It's you don't have it. That is just even the start.
But you promised that you are not going to disclose it.
Yeah, integrity would be compromised and other things.
Somebody just takes it and publishes it. Imagine someone just gets to our medical center now, and those things you told your doctor in the private, are you relating with it? Those things you told your doctor in the private, all the medical checkups, and they just put it in the air, open, for everybody to see. That's what we are saying. Those are the things we are talking about. Those are data breaches. Thank you, please. You can sit. Those are data breaches. All right. The last one now. Of the statistics we have, I want us to take a look at them. Dr. Bismarck, I want you to relate with this. Yes.
Latin America saw a 62% increase in cyber attacks in July 2022, with the education sector being one of the most heavily targeted. In the United States, cyber attacks on schools have led to the exposure of sensitive data of over 1 million current and former students.
I said Dr. Bismarck is in the educational.
Yes. So we are talking about all the information, students that were rusticated, those that failed, those that passed, those that make first class, all the information about each of the students. And I also want to believe that when you talk about education, it's not only the students, even the faculty, the staff, everybody that's related with education are involved. And your disciplinary action taken against people, the results are there, all those are exposed. And obviously nobody wants that.
Thank you. In case you are saying you don't have anything to protect, that's why we are painting these pictures. In case you are feeling you don't have anything to protect, anything to hide. So it's reaching every sector, the educational. We're making points here. What's across? And then we have, according to leaders such as IBM, your cybersecurity budget should cost 9 to 14% of your overall IT budget. Okay, there's this one. This first one that will interest us. 43% of cyber attacks are aimed at small businesses. What point was mentioned about small businesses in the last class by Professor Tako? He said something about attacks on small businesses. What did he say they use them for? Training. So they'll use it for practice. And then when it succeeds. All right, he said 43% of cyber attacks are aimed at small businesses. But how many percent are prepared? So that we're going to be part of this 14% that is prepared. That's why we're having this class. It shows us that people are nonchalant. They don't think, they never happen to them. Something my action is inconsequential. Please, you give Dr. the mic, Dr. Jidoku.
I think it's probably an awareness issue.
Hmm.
Most of the businesses, they are ignorant of the kind of damage cyber attack can actually have on their businesses.
Thank you very much, sir.
And I think the onus rests on us to, let me use Professor Tako's term, evangelize. Yes. And thank you.
Thank you. So we are already taking a step. If you are in this class, you're already taking a class towards security. Okay. So we have been able to establish a background that we are in the cloud, and we have seen why we need security. We are in the cloud, and then we need why we need security. Oh, security responsibilities. Don't forget that we have said that this thing is a joint, it's a shared responsibility, right? Security responsibilities vary depending on the kind of the service model. You will agree with me that security put in place in a factory setting, in an industry, is different from the one you put in place in a living apartment. Do you understand? So this security that you deploy is affected by the kind of cloud service or cloud model you are protecting. So here, basically, we are looking at cloud infrastructure. Three main ones that could be hybrid, but majorly, we have these three models, basically. We have infrastructure as a service. That's why we define cloud computing as using someone else's servers, physical machines somewhere. So that's when we say infrastructure is offered as a service. Like AWS now could buy on demand servers. They could provision VMs for you. So you are buying that they're offering that as a service. And we have platform as a service. Those are the kind of things that are available in cloud services. Can you give us an example of platform as a service? Platform as a service. A platform. Here he said OPay, MoneyPoint. They are platforms offered as a service in the cloud. Then we have software as a service. All right, so whatever it is, kind of service you're offering in the cloud will fall in this three category, and it could be hybrid. So we have seen that cloud services could vary. As cloud services vary, the kind of security we would need will likewise vary. So there are models. And like from the beginning, as we are going, you'll be seeing aspects that have been mentioned even earlier in the classes. So we just have like 9 cloud computing security model. What's a model? Scientists. A model. What do you mean a model? simple as you can have it. Just to give us a framework. Okay? Something else. I could paint another picture. A template, a representation of what it is. That's an engineering dimension. Simulation. Something that mimics, something that looks like, represents every width of that thing. So these ones we have brought forward now represent models. Represent what operations are around them. We have put up 10 shades that we're going to be looking at. Security models. I mean, ways and techniques that have evolved over time in launching security, in staying safe in the cloud. Okay, the first one is the shared responsibility model. Multi-tenancy model. Their names are suggestive. Their names are suggesting what they imply, but we're going to be taking them one after the other. And we have the zero trust model. We have the ID access management, IAM, encryption and data protection. And we have the compliance based. We have the perimeter model and DevSecOps. Does it ring a bell? DevSecOps. Does it ring a bell? And we have virtualization model. And then we have data residency and sovereignty. That one too. Does that one ring a bell? Data residency and sovereignty. All right. Okay? Like I said, we're going to take them one after the other. And there's going to be an exercise. So follow very closely. We're going to have a session with split. No, let me not tell you now. So the first one is the shared responsibility security model. This model advocates, or rather, has this school of thought as a team effort to stay secure. But to be secured, it will take a team. That security is not just one person's responsibility. Security is all our responsibility. It's shared responsibility. It's a team effort. That means between you and the cloud provider, you share security responsibilities. You have your part, I have my part. Then both of us together doing our part, we are both secured. That's what this model perpetrates. This model says we share the responsibility. It's very clear. See your part, see my part. This model says you as the cloud provider, this is your responsibility. And me as the customer, this is what I will do. It's clear. It says that the hardware and the network is whose responsibility? Securing the hardware and the network is the provider's responsibility. And it says the data content is the customer's responsibility. It says the identity management is the customer's responsibility. Physical security is the cloud provider's responsibility. Right? I think this shared responsibility model is where we get to mention that you as a customer, saying that the data content, the identity management, the application level security are all your responsibilities. So since maybe let's say we are customers now, how do we protect data content? Identity management, physical security. Many data breaches happen because of misconfigurations, leaving open ends to the internet, or using something as simple as using weak passwords. What are weak passwords? What would you consider a weak password? Would you consider a weak password? But we all have passwords, don't we? So what do we mean a weak password? He said, your first name. Do you agree? Why is it so? Anybody, every Tom, Dick, and Harry can guess it. So it's weak. Weak passwords. Huh? Dictionary words. What do you mean by that, sir? Any word that is inside the dictionary. You are talking, yes, can be, yes. Dictionary words, yes, Faith. Repeating. Are we learning? Are we learning of birth? Date of birth. Dictionary words. Your first name. Short. 4 letters could be a lot. Okay, repeated digits, numbers or alphabets. Repeated. Yeah, let's mention them. Weak passwords. Weak passwords. Yes, Faith. Some people use their phone numbers. Oh. All right. Our participants online, you could raise your hand if you want to make contributions. We're talking weak passwords. Ready?
Okay, so we have a question from Mr. Shobola Gabriel. What can we say about hackers that hack into well-established or modern-day firm, showing those sets of hackers are more exposed or technologically inclined than the designer or developer of those security technologies?
Okay. I would tell Mr. Shobola to hold on. His questions will be, if at the end of the class his question is not answered, then we can take it up. All right, so we're talking weak passwords. We had so many versions. Some time back, there was, we didn't even see it as a hack then.
Sorry, ma. Someone is trying to answer your question about weak passwords. This one is from Alagat. Short passwords in length. So I think that's with what Mrs. Osho was saying,
yes,
saying
yes.
shots like.
Yes. All right. Yes, I guess that's why you see so many applications saying that your password should not be less than like 8 digits. Do we know why? You know, we have applications that can fiddle with, and then it makes it easy. All right, so let's go to strong passwords now. Strong passwords. What are your ideas for creating strong passwords? Yes. Beautiful. Letters, numbers. You could do
Password. Mr. John, wait.
strong
Yeah.
passwords.
All right,
Listen
let me-
online.
1 2 at and ampersand star then ball.
The Hausa people will say, the Hausa people will say lele. That one is really strong. Okay, but what would you say that is combination of special characters?
Okay, someone from online, Amara Chiata, said password that include a combination of letters, numbers, and other characters.
All right. Thank you, Amarachi. Or at least 12. Okay. From 8. 8 is good. And then okay, so what do we do about maybe some, okay, apart from passwords now, what are tips you have about passwords? About passwords, not just how they are. Okay, I was going to cite an instance that happened some time back. You will pick a lesson from persons who will give their password to someone to do stuff for them. You see someone giving someone your ATM card and then you tell them your PIN for them to go and do a transaction on your behalf. All right, this lecturer, I think, was going to go away somewhere and gave the students his portal password. Or they will say, okay, help me key in or do stuff like that. Until they came one day to pick him up. And there had been some irregularities on the portal. Yeah. And he was responsible. That's what we call identity. Doesn't know whether you are the one behind it, but his password is his identity on the portal. And that was what registered us. The system will not know whether it's your physical self or that's your identity on the platform in the cloud. That's why when they hack your WhatsApp, they post to be you because that's your identity. So you see why passwords are very important. So the students had gone on the portal and they had manipulated the results in their favor. But because they could trail, there was an audit log, they saw that he was the one. At least that's the identity of who they saw. So that's why we're saying, what are tips around passwords? Apart from we have learned to create strong passwords and how not to create weak passwords. What are other tips you may have about passwords? Don't share your password. Don't share your password. Other tips? Unique password for each application. What if I ask, if you forget, if you have too many passwords? Yes. Password manager. You can use the password manager. But what if the password manager makes it easy? Single point of failure. Okay. All right. No. That's why I say it's a discussion session.
What's the place of single sign-on?
Come in there. Okay. All right. Hey. Let's listen. Someone she's saying something here. I hear you.
Thank you. For people that might have issues remembering their passwords, they can just do like a combination of weak passwords. So you can have maybe repeating numbers, the person's first child's name, and maybe their year of birth or something. But just do like a combination of weak passwords, and then it becomes a strong password.
All right. So what do we say about? Oh, please give him the mic. We're just exploring these options.
Thank you. Sometimes what we do at our own side is close to what you mentioned. Try to combine sometimes if an IP address maybe takes 4 octets, and use 2 parameters out of it. We'll pick, it could be an English word as I mentioned. It could be you are tweaking the vowel sounds there. Maybe the A change to at, the L or high, you will find a way to fine tune it so that, okay, you will be able to map it even if you didn't use password manager. You know your kind of system, how you code your password. So this is also another method.
Thank you. All right. Any other tips about passwords?
I think use of consonants, and you could make a sentence that makes sense, and then just pick the consonants maybe from each beginning. Like the rat is on the run, then you pick consonant only from each word.
And that way you can remember easily.
Yeah. So it's consonant.
No. I mean you that made it. That way you won't forget. He's sniffing you. They want to sniff you.
Oh. I don't want to share that.
They want to sniff you. Okay. All right. So password habits. We are just learning password habits. Password habits. All right. So we move to the next model. The next model. So that's not all about shared responsibility. We just had a tip. The exercise will review. All right. So we have zero trust cloud security model. This is another model. Another model that says never trust anyone. Always verify. Assume no one is safe by default. This is what this model says. And it says it's a zero trust model that you have. Just give, this tree is familiar. I've had it in this HPC tree. Mr. Okpe yesterday, he said just give users exactly the right they need. No more. That's what they need to do. He was making an example of like a janitor and somebody that works in the financial department. They can have rights. Both have rights, but they don't have the same privileges. So the janitor is just given right enough to come to the floor, do their job, not more. Just what they need. Maybe say a cashier now. Just enough right to just carry out what they need to do. As the responsibilities are, just enough to do what the person requires to do. keep checking users, devices, and behavior, not just at login. Every step, check. So authentication is not just at login. Maybe you want to use, this is where a single sign-on is coming in. Not as you have logged in, you have access to everything. Check every time, every step you want. And then always act like something may already be compromised. And you're ready at alert all the time. This is what this model teaches. Just be ready to limit damages. All right. Then we go to the multi-tenancy. I'm going to just say little, and then we're going to split into groups. Multi-tenancy model cloud security. Yes, multi-tenancy cloud security model. It's about privacy, separation, and trust. Now imagine a building that has maybe block of flats. And each family in their own flats. You know, the provider has overall security, but everyone has the responsibility to look over their own flat and the content of their flat. This is what this model talks about. We also mentioned the perimeter cloud security. I want to do an illustration of this perimeter. Can you see this? Perimeter cloud security model uses the castle and moat strategy. This picture is painting. I want to say this picture is painting a picture. What do you see? A castle. There's a castle. And around the castle, water, deep waters, a moat. Deep waters. Then do you notice the entrance to the castle? Yes, to the castle. Do you see any other entrances to the castle? One. Inside the water. Land inside the water. Okay, so this technique is the perimeter cloud security model. Assumes that around it, you build security around your structure. And then the security is this water now. Around. There's only a VPN. This gate. There's a snag with this. I didn't say the snag of audio. No, we said, because we were talking about passwords. So this is what this security model believes now. But what can you say about this technique now? Because they all have their peculiarities. What comes to your mind about this kind of security? It's the limitation that we are trying to see. Okay, let's look at it critically. What do you think could be okay, that's a literal thing now. Literal picture. Literal picture. But if you are adopting this, you would have made emergencies. You understand? But I'm saying this kind of security, I've printed it to you. I said this kind of security is saying that you should build a wall around your network. And then this is just your VPN. The only way you enter your network. What? We'll get there. Yes, we have different cloud security models. And I'm just did multi-tenancy. Instead, block of flats. Huh? That's the kind of security that will work for like a block of flats. And then the responsibility. This kind of security model now use action around your network. Only one. Okay, Mr. John says something. Please, can you give him the mic?
Yes, the problem with this is that once you get hold of the strong man, that's the end. If you just get access to the VPN, you have everything.
So let me tell you what, let me now come out with it. This kind of security may not work very well now because people don't work in silos anymore. You really can build, people will really, you really get a network that is just in one place. Do you understand what I'm saying? Like, it's those days that you have organizations that will just be in a network and they are there. But don't you think, you look at it from the dimension of somebody working from home, people connecting from different kind of places, you really can build, even people connecting from different kind of places. So that's the limitation of this kind of network. Okay? Please come up with your argument.
The way you paint it as a VPN, am I correct?
Just the gate.
Just one gate in. Nobody can come in through another point.
Yes.
So they created more or less like there are certain people that can go through it. So quite a number of persons can still connect and get into the room via that same entrance. If you paint it the way you painted it before now. So organization can decide to give that access and say only you know this route. Then you can, those number of persons can go through that route into the apartment.
Yes, but I'm saying that the ease, or this, or in the other way, let me say that this kind of model is variable to those organizations and that's why it's giving way in this dispensation, because it will be a lot more difficult for you to say everybody connecting should come through just that way. Right, so that's the tag. Okay, now, so how much time do I have? So what we're going to do now, let's go back. Please take down the name of this. Take down the name of these models. Can you take them down? Down the name. Okay. Then we are going to split. Why we do that? You are sharing, Abi? I can go ahead. Yeah. Okay. All right, so we have gone through this thing. Just quickly go through this, then we take our assignment. We have seen the landscape of threats. So in the future, what are we looking at? We are looking at, as we advance, as these threats, we are seeing that the landscape will begin to use AI and machine learning to put security in place. Security is going to turn out more and more automated. We're expecting that quantum computing will have more impact in securities. Enhanced privacy measures. And we're going to see how more of regulatory changes. Apart from the passwords now, we have practices that we should get familiar with so that we can be up on security practices. Regular security audits. Employee training and awareness like we're doing now. I'm sure we're going to go away from this class more lighted than we were at the beginning. Incident response planning. We had that too yesterday. If this thing happens now, what are our plans? Salquare dealt with that exhaustively yesterday. And then keeping software up to date. Just our Windows 11, we see updates, asking for updates, and then we feel it will take so much time, we shouldn't do it. They create patches. Is this, you know what they call zero time? Zero time threat. That they exploit. That means there's a bug in the application that even the owner of the app does not even yet know about. But hackers are already exploiting it. And implementing strong access controls. All right, so we go to our assignments. Do you have the names of the models? We have 10 of them. So can we take numbers now? 1, 2, 3, 1, 2, 3. Pick. 1, 2, 3. Yeah. 1, 2, 3. No 3. No 1. 1 again. 1, 2. One, two, three. Let's take numbers in groups. So we're going to split into 3. Where did we stop? We're 3. 1, 2, and 3. 1, 2, and 3. Mr. Taiwo, 1, 2, 2, 3. 1, 2, 3. So now 1, 2, and 3. So 1, 2, 3. 1, 2, 3. 8, 1, 2, 3, and 1. Okay. Quickly, can we split into the groups? Yes. Temporarily, group 1 here. Clusters now. Let's make it fast. 1. Let's cluster here. Okay, group 1. Oh, you are 1, 2, 3. Everybody that is 1 is group 1. Yes, yes, online participants are one group. Everybody that said 1 should come to group 1. All the people that said 2 should go to. Please, let's make it fast. Our time. If you were labeled 1, come to group 1. If you are labeled 2, go to group 2. Yes. Where's group 2? Where's 2? Okay, 2 here. 2 should cluster here. Number 2. Okay, so the group 3 should cluster here. This group 3 should cluster here. Fast. Okay, so yes. So for group 1, take compliance-based cloud security model, write it down, and then in 5 minutes, you give us a submission. Compliance-based cloud security model. Put your hands together, please. Your heads. Okay. We just get information about the model. Yes. And you'll appoint someone to discuss it on your behalf. Compliance-based. Let's come together and just like we said something about perimeter, maybe their weakness, where they are used. Small, maybe 5 minutes. Tell us the strength of that model, where they use the model, and if there's any snag to that model, you let us know it. And appoint the person that will speak on your behalf, please. All right, so group 2. Are you ready? Yes. 2. Data residency and sovereignty. Data residency and sovereignty. So what is the model about? Where are the strengths? Where are they used? If there's any unique thing we need to know about the model. So group 3, no. Actualization model. Yeah. Yes. Where is it used? What are the peculiarities? Do they have snags? They are working together. Oh. And then you appoint somebody, the person that will speak on your behalf. You have 5 minutes. Line participants. Engineer Bola, Mrs. Lawal, you are going to be our judges. Clock is ticking. Tick, 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 tick. I hope you are getting your facts together.
NDPR, which basically monitors our Nigerian data and privacy resource. Then the HIPA is basically for healthcare. So that basically monitors any healthcare solution that wants to come in. I'm just giving an overview of each and every one of these. And PCI DSS is exactly what Mohammed spoke about, which is basically financial institutions and payment solutions I want to bring up, ISO regulations, and the rest of that. So, so this basically just helps us guide each and every one of the models that we're trying to spin up. So where the strengths will come in will be regulation. You can always regulate. There will be mental checkpoints or institutional checkpoints that every organization being spun up has to tick before they are certified as, let's take for instance a fintech company within that country. So that's exactly what these kind of like security guidelines will help us with. So if for example we're trying to make sure that every card on every fintech company is protected by the institution for the clients, then they have to enforce the PSI DSS what's it called, compliance-based model, so that they don't have a situation where something come up and then they cannot basically vouch for a particular institution and say that, okay, yes, we certify that they have the licenses required to hold such data. Sorry, I have to look at my notes for a bit. So another part of it is it helps build trust. If we're basically going through a particular model, I'll use for instance universities again. If we also know that every university always goes through some kind of like quality assurance testing, or some bodies coming to certify that a particular accreditation, sorry, thank you. So that accreditation helps you certify that this particular department or university is fit to, you know, teach that course or teach something. So the same thing for compliance and the institutions. You can build trust, meaning that if anybody should come now and look at the infrastructure within that financial institution or healthcare institution or data privacy or data policy hold or data institution itself, you can certify that you are trusted by the holding body itself. Another point I'll put is that it builds some backing. So if there's any issue that could come up within that institution, you can take them to court. You can actually, so I'll move over to the weaknesses now. So with great checkpoints comes perfectionist mentality. Everybody now wants to make sure that they must make sure that that checkpoint is fully established, which sometimes can lead to his own weakness itself, meaning that you don't have fast-growing economy. People cannot really come up and make sure that their institutions are up. So, so yeah, like it's mentioned here, it's designed to make sure that to pass third-party or government audits. So just in case you want to pass a policy enforcing law, you have to make sure that you're compliance-based, and it's spanned across different organizations like the healthcare, the fintechs, or finance institution, and the government organizations. Thank you very much.
Thank you so much, Group 1. Now, Group 2.
Yeah, good.
Dr.
Yeah,
Ejidoku.
yeah, thank you. The data security and sovereignty model, the basics, the simple basics around the model is that it ensures that data is stored in a specific location and the laws that govern it are strictly adhered to. Then when we talk about the strength of the model, it is just two that I outlined here. It ensures legal compliance with local and global laws, and it also helps to build trust. Then when we talk about the applications of the data security, the data residency model, it is usually applied where sensitive data are to be stored. So, and the kind of data we're talking about are health data that are peculiar to a particular geographical location, finance data, mental data, type of data. Those are the data that are not supposed to be have access to by foreign bodies. So what else? The weakness. Just a minute, Mom. Can you see that? Well, the weakness of the model, the major weakness of the model is the cost implication of making sure that data is resident in a specific geographical location. So thank you.
Thank you.
All right.
We'll be talking about virtualization. Okay. What's virtualization? That's the use of virtual machines. That is some form of a software implementation of a machine on a real physical machine. Now, the advantages, or the usefulness will be that we can simulate or use multiple machines, multiple implementations. We can have, in essence, different servers on one single server doing 1,000 different things. Now, that's an advantage. We can spin up and take down machines as the need arises. We can do backups. We can have a nominal machine that we know always works, and if we have to recover from a faulty or a breached virtual machine, we can quickly bring up another one. So backups can be instant and fast. That also, we can also talk about the disadvantages from that same perspective, where we would usually have a hypervisor or something managing all the virtual machines, and if the management console, the hypervisor is compromised, then basically all the other virtual machines will be compromised. Then there's a possibility of data leaks, particularly if the virtual machine also has to communicate with other virtual machines or the main system that they're all running on. And that would be it. Thank you.
Hello, ma.
Okay. Tell us your name.
Shume for Comfort. So for our group, we have encryption and data protection. Can you hear me, ma?
Ellie, thank you.
Okay. So it involves the use of encryption algorithms to convert readable data into ciphertext, and it involves encryption and decryption. So this particular model is very good as it gives confidentiality, integrity, and reduced risk. But then because of the encryption model that has different types, the encryption could be symmetric, it could be asymmetric. There is the issue of key management, and it also requires regular updates. And areas where it is being used, we have online transaction. When we receive details from the bank, you discover that financial institution, they will try to turn those plain text to ciphertext to try to protect our credit card information. Also, it is also used in healthcare for protecting the information about the patient. So this is a little as a common people.
Your hands together for the online participants. Thank you so much. I'm going to leave the floor open in case you listen to the arguments of other groups and you feel there's a gap that was not covered. You can add to the mark of your group by bridging the gap. Do you understand? Probably you listen to the presentation of the other group and you feel there's a gap. You have the opportunity to enhance your group by bridging that gap. Probably we're not listening to. Okay, so if there's a gap that you feel exists, while other groups other than yours were presenting, and you want to bridge the gap to enhance your own posture, you have the floor. Okay. So indicate if you want to enhance your, yes, even if you feel your group did not and you want to add to it, you have the opportunity now. Before I give the judges the floor, and you want to enhance, so both ways to enhance your posture as a team. All right. Have group one again. Group one wants to enhance their posture by beefing up what they said and by speaking to what other groups said. So you mentioned the group that dealt with it, and then you tell us your addition. Thank you.
Thank you, ma.
Tell us your name.
Thank you. My name is Oba Emmanuel. So they spoke about data. Hello, ma. Sorry, can I get the slide? Yes. So I think that is also in line with what we spoke about earlier today. We having federated platform, and we host our data by African, for African, and by us. So, yes. So, in line with that, I felt they didn't really bring the part about we hosting the data ourselves and we managing the resource ourselves. So we dictating what our data will be used for and how our data will be interacted with. So yes, data residency and sovereignty. So yes, that's yes. So I said
you spoke about.
I said it's in line with what Prof was saying earlier, where we have data and we govern our data ourselves, how we want the external world to interact with it. So it's that us, by us, and through us. So we own the platform. We make sure that our data, we set the laws that favors us and how the Western world interact with it. That is giving us the sovereignty to dictate how we others interact with our data. So I just felt they didn't really hit the us handling the data, but the platform itself. Yes.
Thank you, Mr. Oba.
So
that's one leg. You said there
no,
were two.
yes, the is us. So we spoke. Please.
Your
compliance, yes, ma'am.
Compliance.
So compliance based, and so it's the models here just generally shows the different regulatory framework based on the organizations. EU, which are the ones that came up with the GDPR to help protect their indigenes and how their data is being interacted with, while the HIPAA is for healthcare. So what this simply do is it creates a clear, concise framework in which you could simply tap into. You don't have to start thinking, what are the things I should put in place? So if you just want to come into the field, you simply have, okay, these are what you should live up to. And so that creates a level playing ground for everybody across the field and something to benchmark on. So when there's a bridge, we know where to tackle it from. Thank you, ma.
Together for group 1. All right, so can you give the mic to group 2 now? Group 2 now.
Thank you. I would like to make. I would like to talk about.
Let's make it snappy now.
The
We need to go on
presentation
break.
done by the group 3 and talking about virtualization.
We can't
Some of
hear
the
you.
features. Some of the features virtualization support. Maybe one or
Let's
two.
listen. Let's
one
listen.
one or two wasn't mentioned. One of such is high-speed storage. You can easily attach or expand virtualization by maybe having a network attached storage to it, so you can easily expand, scale it, and get it bigger as your maybe data center increases. Also, it support high-speed network. And also another area he mentioned was maybe con of virtualization was maybe security, because sometimes virtualization, maybe the VMs might communicate with each other, but there are internal security in all these specialized hypervisors too that can create something like access list, filters, and ensure security that we are thinking that could be an issue that can be taken care of. And also open source technologies too, and hypervisors are getting more versatile, so that the way hypervisor are now designed is getting similar to maybe cloud solutions that if you have the skill set, you can even migrate from your virtualization to cloud orchestration and from there. So I believe technology is moving very fast in the hypervisor and virtualization world. Thank you.
Group 3, do we have Thank you. Thank you.
Okay. Okay. Thank you for the comments from Group 2. Perhaps maybe just brought to mind that maybe if we look at it from perspective of risk, where though you have a solution to the security problem, as it were, but if someone can overcome your solution, as it were, then whatever your solution is has gone out the window. So when you say, okay, with virtualization, okay, you can centrally manage your your virtual machines, you have security policies you can implement. It gives you an advantage, quite all right. But it's also a risk as a single point of failure. So that's just the perspective. The additional information about high-speed storage, I think those are just more general ideas, not limited specifically to whether you're using virtual machines or not. There's a lot to say, but we know that our time is short. Thank you.
As we round up, I admonish you to take a look at the summary of what everything we did, and you still have the slides. I believe you'll still be going through them. So we call the judge, Engineer Bola, to give us assessment of how we did.
Thank you very much. It's been a very, very wonderful discussion, and I quite appreciate everyone's contribution in this discussion. For me, I've learned great things. I've learned quite a number of things, new terminology, and better understanding to some terms. So from this group, we had 4 groups, and then each group discussed a certain topic, and I'm grading each group based on 5 points. Yes. And number 1 is regarding content and clarity. Content and clarity. Then clarity and articulation. Let me just say articulation. Confidence, team behavior, and originality. Jiwewo. I can solo read. So for group 1, content clarity. Each is 5 points and is over 20 for each. For group 1, content clarity 15 over 20. Articulation 15 over 20. Confidence 18 over 20. Team behavior 15 over 20. And then originality and creativity 16. They discuss on compliance-based model. Am I correct? Yeah. So in total, they had 79 points. A round of applause for them. There's going to be gifts for each group. First, second, and third position. We're giving you gifts. So just be highly expectant. You'll get your gift before you go on break. You are getting your gift as a group. Okay, so for the second group, that's group 2, you discuss on data residency and sovereignty. Am I correct? Okay, so for content clarity 14, articulation 13, confidence 17, team behavior 14, and originality 14. In total, you had 72 points. Yes. For group 3, content clarity 13, 13, okay. Team behavior 14, originality and clarity and creativity 14, total 70. Clap for yourself. Then for the online clarity, articulation 13, confidence 14, team behavior but we managed to give them 12 because we are not seeing the team behavior. Then creativity 13, in total 64 points. So the first position goes to group 1. Just in that order goes to group 2, and then the third position, group 3.